very glad today to be with Dr. Noel Aloysius. Noel is one of those unique individuals that holds a faculty position in both CAFNR and engineering.
That's correct. Yeah.
That's right. So you have a very unique way of looking at things. And this is a giant vegetable study that you're doing, but you're doing it with some high technology. So tell us about what you're doing.
So the idea behind is, can we develop a small scale system where you could go be off grid and then grow some fresh produce that can become maybe a small business, right? So that's the experiment here.
High value crops.
High value, particularly high value
Right,
crops. That's right.
So you're using, but using technology to get off the grid.
That's right. So what we have done here, we have a solar system, solar panel. That's what you see here is about 800 watt panel that is recharging a deep cycle battery. We have an inverter that provide power supply either in AC or DC current. System, it is connected with a submersible pump where you have about 1,500 gallons of storage tank. So what we are doing here, this is off-grid with the power supply and all monitored systematically, how much power is being used, how much is generated. The pump is controlled. We can operate the pump at different speeds and different discharge rates. So that is the system. It's mounted on a trailer. So if you have multiple farms, you can actually move things around and then use the system. We can also expand the capacity by adding multiple panels. That way, if you need more power, it's a modular structure. It can be expanded.
And so you're also monitoring how much water to give your plants.
That's right. So the second aspect is, we know a water source. We know we have a power source. We also, based on the current weather conditions, the past week's weather, we have an atmospheric scientist who provides the next 7 days forecast, based on which we can estimate the irrigation requirement for the next 5 days or the week. So the students, they would use that weather report and then decide how much irrigation we need for these different plants, and then they do the scheduling.
So you're not underwatering or overwatering.
That's right. So we want to manage the water use more efficiently. That way we do save water as well as energy. That, you know, if you are on a public water supply, it's going to be a lot of money to pay for it. Or if you are if you're using a groundwater well, the cost of pumping water itself, it adds up, right?
And also to getting that well, that's a great point, is that this way you don't have to have a well. And you can take your water system somewhere else. You can transport.
That's right. So if your water source is a pond or a well or a public supply, you know, it's kind of mobile system.
That's great. That's great. Now this is important because we're in an ever-changing environment now, aren't we?
That's right. So what we have done, our other research activity shows the weather patterns, particularly rainfall patterns, are changing. We get more intense rainfall during a short period of time, followed by long dry spells. So if you have a system, particularly for smallholder farmers, this will help them to avoid that water stress conditions where you are more flexible in terms of when to apply water. Our idea is actually to expand this current forecast combined system so that any farmer in the state, in Missouri, will be able to look at the weather forecast for the next 5 to 10 days and plan their activities.
Wow, so you don't have to have any kind of special equipment, just use your local weather.
That's right. So you could probably subscribe to our forecast system, and then you will get your forecast delivered to your inbox that way. So that is the kind of system we are moving towards. Here is the first step. We are experimenting with it.
So are you adjusting your watering like to different plants, tomatoes or versus a smaller plant?
So this is our second year of experiment. Last year we had some difficulties in getting the system off the ground. So if I explain what we have here, we have about 10 different varieties of high value vegetables, okra, some herbs, different kinds of peppers, different kinds of tomatoes. We have some mums that are growing, and we have some cut flowers, right? So we have a mix of things where something is growing throughout the growing season where you can harvest and make a living out of, right? So that means the water requirements for each of those are different. So we are trying to optimize so that we don't over apply or under irrigate different crops. So the system, the way it is set up now, each row can be controlled. So if particular plants, say tomatoes, need more water this week, we can actually apply that amount only tomatoes by turning off the rest of the system. So this is a drip system. We can extend this to a sprinkler or other forms of small micro irrigation setup.
But a drip is a lot more efficient on your water.
That's right. So drip is more efficient. It's probably the overall efficiency is somewhere around 80 to 90%. So the wastage is less.
And these are plots that can be reused next year. You don't have to rip the mulch off. You can.
That's right. So that is our idea. So typically, this system we should be able to continue for the next 3 to 4 years. We also have an arrangement where we can actually inject fertilizer. So that also we can control. Say we want to apply this kind of fertilizer for peppers or for cut flowers. So we can decide what to apply, when, and how much. So all those things it can be controlled based on the need.
So like right now, our tomatoes are needing calcium nitrate.
That's right.
So you can inject calcium nitrate in this system with no problem, and not also give it to your cut flowers.
That's right. So we can say if you don't want any water that's been applied to cut flowers or fertilizer, we just turn that line off.
That's great.
Right. So that's the idea.
Or the other way around.
That's right. So the other aspect is, we have undergraduates and graduate students working on it. So another thing that on the science side of things, we are also monitoring soil moisture. Every 15 minutes, there's a data being recorded.
Oh, wow.
Different depths. There are about 8 sensors here. And then we also have a drone program where we fly the drone every week. So during the growing season, we can exactly identify the growth profile of different plants. And then we can see, based on our applications and the soil moisture variations and the local weather conditions, what the growth cycle is, the plant growth phenology, right? That way we will be able to improve the system performance when we revisit the design next year.
Sure, to be more efficient, again, with our growth. And I imagine you'll find some things that we take for granted that we were wrong.
Yeah, that's probably, we may be able to find some of the
right. Because I say right now, I'm kind of jealous that an engineer has grown better tomato plants than I have. I think yours are in better shape, so I'm really jealous.
Well, we will definitely provide what we learned from this one for you for the next year.
Well, because, we had almost 10 inches of rain the first part of July. So we got over irrigated, but so I just thought, well, I got plenty of moisture. But with those sensors, you were probably telling us you need the water.
That's right. So that's our next phase, right? We are collecting all this data with the drone, how the vegetation grows. So going back, once the season is over, we will revisit everything that we did. Whether we had enough power, whether we over-applied or under-applied water, how can we reschedule, how can we develop a better system to schedule irrigation. We are also trying to see if we can, using the weather forecast, and if we can add another sensor where we don't have to come to the field every day, whether we can automate the system through remote application, things like that. So those are some of the things that we are trying to.
And you can regulate quality too. I mean, have an underground system, you don't have the quality issues of a sprinkler.
That's right.
Getting on your plants and causing issues.
So it's delivered right at the root.
Right.
So that's the water is delivered, or fertilizer is delivered closer to the root than just spreading it elsewhere.
You know, 25 years ago when we started scheduling corn irrigation, and versus just going off what we thought,
Yeah.
I was shocked how much we were under irrigating.
Oh yeah. Okay.
And I think that's what we're going to find here is that our plants may be more watered than what we think, but if we're doing it with drip, we can get by. We can do a lot better economical job irrigating.
That's right. So the whole idea is, for the larger systems, there is enough equipment and sensors. So our goal is, can we develop this for a smallholder farmer who want to do it as a part-time job?
Sure.
So that's the challenge we see if we can solve or provide a design.
All right.
So what we find recently is, water is becoming not much of a critical issue, but weed control.
Oh, weed.
That's the problem that we find. So we'll have to go back and see how we can work out something.
Well, weeds like water too.
That's right. So we are providing water for the weeds.
That's right.
And we develop something to control them. Currently, we have this the
fabric, kind of a weed mat.
Yeah. However, in between, that is going to be a problem.
But I also like that you're using a living mulch in between the rows.
That's right.
And that's building soil health. In the future, what you could do then is just move over a few feet and grow your vegetables right where you had that living mulch for several years.
That's a good idea.
That's it.
Yeah. We will do that.
That's right. That's right.
I'm hoping we will be able to continue this and improve the system performance over the next few years. So maybe that is something we will
That's right.
try maybe 2 years down the line.
That's right. All right. Well, thanks so much, Noel. It's great working with you. We got a lot of great ideas, and I look forward to talking to your students about all that they have learned and the opportunities that studies like this gives them.
That's right. So we have about 4 or 5 different students, including undergraduates, graduate students, working on this. They are doing actually the hard work. I'm just here.
Yes, right.
Looking at and seeing.
And consuming the produce.
That's right. That's right. So ideally, we are also trying to reach out to local food banks where the produce can be delivered. We get a lot of produce. The yield is going to be a lot more in the coming weeks. So.
And we'll follow up with you on what you found out after this year.
Yes, definitely.
All
right. One of our students is developing a design that we hope eventually will become an extension publication.
Perfect.
That way, somebody with the list of things can build a system like this. That's the idea.
All right. Well, thanks again, Noel, and we'll be looking forward to your results.
Thank you for the opportunity.
All right. We'll see you.